So here's our first example. I want to find the partial derivative, the first partial. Now the thing about partial derivatives, and when I talk about maybe a first derivative, there are two of them. There are two first derivatives or first partial derivatives. I can do a partial derivative with respect to x, and I can do a partial derivative with respect to y. So I'm going to do the partial derivative with respect to x, and we write it like this. This is one of the ways to write it. There are other ways, but f with a lowercase x tells me I'm doing the partial derivative with respect to x. And what you do is you just do a normal derivative, but y is treated as a constant. That's it. So, since I'm going with respect to x, I'm looking at 4x cubed y to the 5th, and I'll do the derivative. 4 is a constant too right there, but if you want to look at it as this, you could, and then times y to the 5th. All you do is do the derivative of the x cubed. What's it going to be? 3x squared there. So 4 times 3x squared, which will be 12x squared, if I take that 4 as part of the whole picture there. 12x squared. Since y is a constant, you keep, or y to the 5th, you just keep it right there, just like you would keep any other constant. Just like I kept the 4, but I went ahead and multiplied it with the 3. Now, I got minus 6x squared. I'm doing the derivative with respect to x. So what's the derivative of 6x squared? That's minus 12x, okay, because I got that minus sign. Now 2y is a constant, and the derivative of a constant that stands by itself is 0. There's a partial derivative with respect to x. Let's do the partial derivative of this with respect to y. So I write f, a little y, sub y of x, y. Now this time x is a constant. So this little part, I got 4x cubed, that's a constant. I'm just going to write it, 4x cubed times, what's the derivative of y to the 5th? 5y to the 4th. 6x squared is a constant, so that derivative is 0. And then 2y, I'm doing the derivative with respect to y, so the derivative of 2y is 2. Now you could, on both of these, you don't have to write those zeros. I wrote them so that you would see, you know, I really did do the derivative of 2y and I got 0 right there. And I did the derivative of 6x squared and I got 0. I put them to emphasize that we did do that derivative, but here, my answer for the first one, 12x squared y to the 5th minus 12x. And the second one, well, we can multiply 4 times 5 and get 20. 20x cubed y to the 4th plus 2. There's the two partial derivatives, the first partial derivatives on this problem. Well, I could do a second partial derivative, and one way to write that maybe would be this. I can do f, that's my first partial, and then my second partial, I'm going to go with respect to y. So what does that mean we're doing? I'm going to take my first partial derivative, this answer, and now do the derivative of this with respect to y. So I have 12x squared y to the 5th. This time x is a constant. So 12x squared, then times the derivative of y to the 5th. That's going to be 5y to the 4th. X is a constant, so what about the derivative of 12x? 0. So I could multiply this. 12 times 5 is 60. 60x squared y to the 4th. There's the second partial derivative. First with respect to x, then with respect to y. Okay, I'm going to do one more here. I'm going to do the derivative first with respect to y. So the answer from here, then with respect to x. And let's see what we get here. So I'm going with this answer. This time, I'll take this answer, and y is a constant. So I need to do the derivative of the 20x to the 3rd. What will that be? 60x squared, y to the 4th, because y is a constant. 2 is a constant. The derivative of 2 is 0. So I get 60x squared, y to the 4th. Now, this problem does illustrate something that is important to know. That a lot of times, if I do the derivative with respect to x and then y, I get the same answer. If I do it the other way around, the derivative with respect to y and then x. So this fact is called Clairaut's theorem, and I'll write that next.